I'm Chris Gerdes, Professor Emeritus of Mechanical Engineering at Stanford University. Let's answer some questions from the internet. This is Automotive Support. At Punicist wonders, I wonder why solar-powered cars aren't a thing yet. So if I take the Mercedes behind me, that's a really large car. I could fit maybe 4 solar panels. Each of those under peak conditions would produce about 400 watts. Put it together and I have 1,600 watts, almost enough to power this hair dryer, somewhere on the order of about 2 horsepower. How do self-driving cars see? Self-driving cars can use a range of different sensors. Radars can be very helpful sensing metallic objects that are near the car, but sometimes it's hard to tell exactly what that radar is bouncing off of. Cameras give a picture of the world that's not unlike what we see with our eyes, but it doesn't really give you distance information. Finally, LiDAR, or laser scanners, this is a series of beams of light that tells very precisely how far away an object is from the LiDAR. You'll see that the LiDAR is spinning on top of our X1 vehicle behind me right now, and it's painting a picture of me sitting here at this table. So if I move my arms, you can see the image move. Each one of these lines represents one of the spinning lasers. The color tells how intense of a reflection the laser is getting. So autonomous cars see by using a variety of sensors and AI to turn all of these sensor signals into a picture of the environment. Why do autonomous vehicles have steering wheels? Our federal motor vehicle safety standards are generally interpreted to mean that all cars have to have driver controls. It's easier for manufacturers to simply leave the steering wheels and driver controls in the cars. Engineers like to talk about levels of automation. A level 1 vehicle is a system with an adaptive cruise control, something that uses a radar to follow another vehicle safely, or a lane keeping system. A level 2 combines these two systems, but the driver needs to remain with their hands on the wheel. A level 3 autonomous vehicle, that's this Mercedes EQS here, that car will actually drive itself in limited conditions in traffic jams. The driver can take their hands off the wheel and their eyes off the road. A level 4 automated vehicle is a vehicle that can drive itself within a specified area. These driverless robotaxis that you see companies like Waymo or Cruise. Level 5 autonomous vehicle is really the highest level. That's a car that can drive from one point to any other point that you want. That car obviously won't need a steering wheel, but that's a long ways off in the future. Drove down I-40 earlier and hit a long and indistinguishable object fallen from the car in front of me. My car drifted at high speed for about 5 seconds. Wonder how autonomous vehicles will react to this. Autonomous vehicles need to react to unexpected situations on the road with skills that are as good as the very best human drivers. So you're telling me that if someone puts up a sign with the image of a green traffic light, it will confuse autonomous cars? Maybe. If it's using cameras to try to make sense of its current environment, it may very well be looking for traffic signals. If it finds one on the back of a semi and not actually signaling an intersection, it could get confused by that. One of the difficult things about programming autonomous cars is you have to think in advance about things that might confuse them. News reports from San Francisco show that people have been able to confuse Waymo cars by putting a cone on the hood of the car. That's something I doubt any engineer would have thought about when they were designing the automated vehicle. Why does people getting crash when they have on Tesla autopilot? So psychologists know that if we don't have enough to do, our mind wanders, and it's hard to keep our attention on being ready to take control if we need to. Tesla's autopilot are level 2 automation systems. They require the human driver to be engaged and in control all the time. This is a challenge that the whole industry faces, and they're working on different solutions to warn or re-engage the driver. Self-driving cars running with AI present a new version of the trolley problem. How does the car make an ethical decision about who to kill by running over? So in one classic version of the trolley car problem, you're a bystander and you see a trolley headed towards 5 people on the track. You can switch to another track where only one is killed. Do you pull that switch? Automated vehicles have to consider situations where there may be loss of life, but they're not really using this sort of moral calculus. Part of my work with a safety advisor for Ford, I actually helped develop a set of rules that autonomous vehicles could use. And this just simply involves following the duty of care that the law outlines. Now, if other people violate their duty of care to the car by jumping in front of it when it doesn't have enough time to avoid a crash, you can program the autonomous vehicle to do the best it can, to do everything under its power to avoid that crash. Autonomous vehicles are out there protecting people who follow the rules and not making determinations about who's more worthy to live or die. At Aote asks, if my self-driving car gets into an accident, why wouldn't whomever made the car be at fault? I wasn't driving. If a car is driving itself, the manufacturers will, in general, be liable for that. Mercedes has already made a very strong statement with their Level 3 Drive Pilot that if it has a crash, the company is responsible and not the human driver. So we're shifting really into an entirely different world. In fact, in San Francisco, they've already run into the problem of how does a police officer give a ticket to an autonomous vehicle? That doesn't make sense when there's not a driver. If you had to solve real-world driving, would you go down the path of programming the rules of the road and expect the car to obey, or let a neural network learn to drive like an experienced Uber driver? You really want a combination of these techniques. So Tesla, they use neural networks to learn from their camera system and what the cars are likely to do around them. In contrast, Mercedes' Level 3 system tends to rely on rules. Engineers can program specific behaviors into the car to ensure that it follows the traffic laws or follows a vehicle at an appropriate distance. I'm really concerned about security when autonomous cars take over. What if they're hacked? Hacking is a real concern with automated vehicles, particularly those systems that can receive over-the-air software updates. There's also a threat as we move towards AI systems that hackers could get involved with the data stream. AI in an autonomous vehicle is trained by feeding it lots of data, which could be, for instance, a series of camera images. If you could hack that set of images, you could make it so that the vehicle failed to recognize certain objects in the environment, and that could create some serious safety risks. Will autonomous vehicles reduce the number of accidents? So autonomous vehicles will certainly eliminate some forms of human error. Autonomous vehicles don't text while driving. They don't drive impaired. They're never distracted because they can see 360 degrees around the vehicle. Autonomous vehicles won't eliminate all errors, but they will shift from the human driving errors to the programming errors. Over time, that should be a shift towards safer cars. So those are all the questions for today. Thanks for watching Automotive Support.